All right, go ahead, Catherine. She put in roughly 40 mils of distilled water. I occasionally buy gallons of distilled water, and she's putting in just 3. That's more than enough. Oh, 2 big chunks. Perfect. Close that up. Immediately, Connor, can you come in on that? Look at what's happening. We also need an indicator. Put in 3 drops, please, of this indicator. So you can see there's gas coming off the calcium right away, okay? This is an indicator that indicates the presence of a base, okay? It turns pink in the presence of a base. Perfect. Okay. Move this here where he can see it. Now, number 4, what are my reactants? Somebody new and different. What are we reacting in number 4? Right, read. In a small beaker, she added about 40 mils of distilled water with 2 or 3 drops of the phenolphthalein. PHTH is phenolphthalein, okay? And she put in 2 bigger pieces of calcium, getting a good reaction. Here, right over here, Connor. Bubbles. It's turning bright pink, which means there's a base present, okay? What are we reacting? What's calcium? Okay, I forgive you. Calcium. What is it reacting with? Water. Well done. There we go. Water. What's the formula for water?
H2O.
Right. Who remembers the formula for calcium?
Ca.
Well done. And okay, PHTH is phenolphthalein. Notice again, I'm putting it over the yield sign. It is an indicator. It isn't part of this reaction, okay? You're getting this. Did you get also the board? Good job. You're doing a great job. This calcium is so reactive with water. I want to show that, and I have all kinds of evidence. Look at how, again, it continues to react, bright pink bubbles. It specifies, do not test the gas. Why do not, no, wait a minute, hold on. Somebody new and different. No, put your hand down. Okay, Sophie, why shouldn't you test the gas?
Because it has oxygen.
There's another, we tested oxygen with the manganese dioxide and the hydrogen peroxide, no problem. Do not test the gas, why not? All right, go ahead.
Hydrogen.
We're getting hydrogen, but what is the problem?
With oxygen.
No.
The calcium gas will blow up.
No, it has to do with the amount of hydrogen. Hydrogen, like think of the Hindenburg, okay? Hydrogen, there's too much there. We could have a big explosion, rather. Okay, there's too much here for us, okay, to actually test it. It says do not test it. Now, so what we're going to do then is, what are we getting? What did we just say one of the products has to be? Hydrogen gas. Hydrogen, what is the formula for hydrogen in its elemental state?
H2.
H2, thank you. What's the other compound have to be?
Oxygen.
No, we're not getting oxygen here.
Calcium.
Calcium compound. What calcium compound? Any idea? Let me give you a hint. This pink means there's a base. Common hydroxide are the base. Most of the common bases, the inorganic common bases, are hydroxide. Calcium hydroxide, potassium hydroxide. So this must be, what kind? It's not going to be potassium hydroxide. Which one's going to be?
Calcium?
Because we have calcium, we don't have potassium. Calcium hydroxide. Okay? Calcium hydroxide. What's the formula for calcium hydroxide? Raise your hand, don't call it out. Go ahead.
Wouldn't it be COH or CHO? CAHO.
OH.
OH. That's close.
Now, OH is -1. How many do I need? I heard it.
2.
2, because this is -1. Calcium's in group 2. It's +2. Now, is this balanced?
No.
It is not. What's the trick for balancing this? I have water and I have a hydroxide here.
Turn water into HOH
And then it'll balance much. Exactly.
OH and then H.
Exactly. In fact, what do I need to put in front of the HOH?
2.
Well done. And now it's going to be balanced. Okay? What type of reaction is this? I heard it. Single replacement. Calcium's bumping out the hydrogen. Okay? And we're getting the calcium hydroxide. Go ahead and stop.